So first of all, the contents of the exam, the material you're tested on in the exam comes primarily from part 4 of the course, right? So it's mostly the stuff, some inheritance stuff, and some generics. The types of questions you're going to see. The format of this year's exam is pretty similar to the format of this exam. And you can find this exam on ExamBank. I checked last night, it's definitely there. All right, so the first set of questions is just some very short answer questions, right? Notice the instructions up here, right? Use one short sentence, complete each part. I don't need a lot of exposition here. You don't have to explain your answer, but it doesn't ask you to explain it. You just need to answer the question, right? And so the space that you're given is small intentionally. Okay, question 1, what's the purpose of an iterator? Right, so an iterator is just an object that knows how to iterate or visit elements in a sequence. That's all you have to write, right? So that would be your answer for part A. Now part B asks you, right? So in our linked list implementation and its iterator implementation, there was a method called remove, right? So both the linked list had remove, the linked list itself had a remove method, and the iterator also had a remove method. Right, so the question is why did both classes provide a remove method? And so the answer is because the only safe way to remove an element from a collection while you're iterating over it is to use an iterator. Does everybody have their test? Does anyone need test 3? You guys who just came in?
You test that.
Test 2, yes. Test 2. Test 3 would be. It's sorted by less. Oops. Okay, so why did they both provide remove? Because this is for linked list, so it's asking if you link for linked list specifically, right? So the linked list version of remove runs in O(n) time, but the iterator version of remove runs in O(1) time. Is that it? So it's useful. I think it real sense. So each class needs its own version of remove, right? And so just to quickly expand on this answer, I've got a little example here. So there's a method here called bad filter. It takes in a collection of strings in this case, right? So remember what a collection is, it can be a set or a list, right? So any set or list you pass to this method and it should work, right? As long as the set or method supports remove. Right. And so what this method does is it removes all the strings that are quote unquote less than n from a collection. And so this example is nice for 2 reasons. It's going to iterate over a collection and try to remove stuff from it. Right. So for every string in the collection, right, we're going to test whether or not the string is less than n. Right. So this also reminds you that for objects, if you want to compare them for order, you're probably going to need a compare to method, right? There's no less than or greater than for strings, so we need to use compare to, right? So if s compared to n is less than 0, does s come before n in the dictionary? We're going to try to remove it. And so in our main method, I'm going to make a set. You could also make a list, it doesn't matter. Right? I'm going to populate the set with a bunch of strings, so these are just a bunch of fruits. Right? I'm going to add the strings to the set, and then I'm going to try to filter the set. So I'm going to print the set of strings before I call filter. I'm going to try to print the set of strings after I call filter to see if they've actually been removed. Right? Everything here looks like it ought to work, but when you run the program, it barfs. Right? You end up with an exception down here. Right? And you end up with a funny exception. It says there's something called a concurrent modification exception. And so this exception is coming from up here. Right, and so what's happening is that you have a for each loop. So you actually have an iterator up here. Right, that for each loop is actually implemented using an iterator. Sorry, right. That iterator is iterating over the list C, but then you're using C to remove an element from the list itself. So you're modifying the list as you're iterating over it, and the iterator doesn't like that. Right, and so it barfs, right? So remember, the iterator is the thing that knows how to visit the elements in the list. If you change the list, or sorry, of the collection, if you change the collection without telling the iterator, the iterator is going to have problems iterating over that sequence, right? And so it barfs in this case. So what is the correct solution? So if you want to do this sort of thing, and it's fairly common that you want to do this sort of thing, you need to write an iterator-based loop yourself. So the way you would do that, I guess, call this good filter. Right, so instead of using a for each loop, you're going to explicitly create an iterator-based loop, right? And so the way you do that is the following. So you're going to make an iterator object. It's going to be an iterator over strings because that's what my collection is. Right? I'll call it iter. Right. Now, where do we get the iterator from? You ask the collection for its iterator. Right. So C iterator. Okay. So how do you? What is the condition for the loop to run? Well, the iterator has to be able to look at another element. Right. How does the iterator know if it has to look, if it can look at another element? Well, there's a has next method. Right. What is the update condition? So it turns out in this case, there is no update expression here. We're just going to use next to advance the iterator to the next position, right? And so inside the loop, you're going to get the string that the iterator wants to look at next, right? So string s equals iter next, right? And now you can compare this string to n, right? So now you can write this. So if s compared to n is less than 0, so does s come before n? Right now, instead of telling the collection to remove the element, right, we're going to ask the iterator to remove the element. Sorry, iterator remove. Right now, remember, remove removes the element that was most recently returned by next. Right. So in other words, it removes whatever was returned by that. And if you change bad filter to good filter, and run your program, everything works the way you expect it to, right? All of the fruits that began with the letter not equal before n are now removed, right? So apple, lemon, and banana all got removed, are set. And so that one little question, right, actually is hiding a lot of stuff that we learned about in the course, right? There is an interface here. Oops, sorry. There is the use of an interface here, right? There's the use of an iterator up here. There's another interface here, right? And so on and so on and so forth. All right, so that's part B. Part C. So this is just a little question asking if you know if you remember what the complexities are for the common operations. What am I asking you for? In this case, a list and a queue, and these are both array-based lists and queues. Okay, so what's the average complexity of adding an element to the end of an array-based list? Right. So most of the time, there's room in the array, so you just add the element to the array. Right. So that's O1. Okay. However, every once in a while, you run out of space in the array, have to expand the size of the array, so that's big O of n. Okay, you want to remove the first element from a list. So that's always bad from an array-based list. That's always bad, right? You remove the first element from a list, you have to shuffle all of the elements forward one position. So that's always ON on average and in the worst case. Now, what about a queue? So the queue, for an array-based queue, we implemented it differently, right? We kept track of where the front of the queue was. Right, in the list, we just assumed that the front of the list was always at index 0. So when you add to the element of to the end of an array-based queue, it's exactly like adding to the end of an array-based list. Right, most of the time, you don't do anything. You just add the elements to the array. Every once in a while, you have to expand the size of the array. This is where the difference is. So when you remove from the front of an array-based queue, because we implemented the queue as a circular queue, we're able to do that most of the time in what is going on in big O1. Oops, sorry, big O1. Ugh. And on average, it's also big O1. Sorry, in the worst case, it's always big O1 in this case, right? Okay, another, so this is a question, says you have a list of string. And it's basically asking, do you not know how to use a map? Now, we didn't really use a map a lot this year in this course. So it's unlikely you're gonna see a question that looks exactly like this, right? But it's not a hard question to answer, right? So if you think about what a list is, right? So in a list, you're able to access elements by an integer index, right? The index is unique. In a map, you access elements using a key. Key has to be unique, right? So it looks like for a map, it's pretty straightforward if you wanted to act like a list, or if you wanted to have a map that provides the same functionality as a list, right? You make a map, right? What's its key type? Well, the key type is an integer. It's going to be it's going to correspond to the integer index for our list, right? It wanted a list of string, so our value type is going to be string. Oops, sorry. Right, and now you pick a map of some kind, so I'm just going to use hash map, but you can use whatever map you want. Right? And away you go. Right, so that's all you would have to write for that question. Right. Okay, so why do we use generics in Java? It's because you can write one class, right? Write one generic class, and that produces a class that conceptually behaves like it was many different classes, right? So you get an array list of string, you get an array list of integer, you get an array list of double, right? You get all of those things just by making the one class array list. So that's nice, right? It's also type safe. There's a lot of ways you can answer this question, right? It's type safe. You can probably come up with other reasonable answers as well, right? Most of the time, I'm not looking for one specific thing, right? If there's multiple different valid answers, I will take any of them. Okay, classes can be generic in Java. What else is generic in Java? Well, what else is there? There are interfaces, right? And there are methods, and that's it, right? So that would be the answer there. This is a little inheritance question that's also related to generics, right? And so this is basically asking if you remember how arrays and generic classes behave in inheritance, right? So if you have an array of objects, is an array of string also an array of object, right? That, remember, this is the inheritance UML diagram, right? So the answer is yes, that's true, right? An array of string is an array of object. Right. So obviously the reverse is not true, right? Inheritance is always one way. So an array of object is not an array of string. So that's not correct. Right. And now you have these generic types here. So when you specify the type, so set of object, set of string, there's no relationship between these two things. Right. A set of string is not a set of object, right? A set of object is not a set of string. Right. Now, if the type wasn't actually specified here, right? So for example, if you had set, sure. What would be a better example here? So if you had something like, no, counter doesn't work either. Even the set thing here is not totally correct because this is using inheritance here, which isn't precise, isn't exactly correct because these are interfaces. But if you had set E and then set string, right? So a set of string is that true? No, sorry. Set E, and then you had something like sorted set E. Then this diagram would be correct. Right? But as soon as you specify the actual type here, it's no longer correct. Right? So once the type is specified, there's no relationship between the two things. This is just asking if you remember what the node class looks like. Right? So what does the generic node class look like that we've been using all along? Well, it can hold an element of some type E, right? What are its fields? A link to the next node in the sequence. Oops, that. And so that's what our node class looks like. So that's pretty straightforward. And then finally, the stuff that we talked about, I guess, in the previous lecture. So this is an actual generic question, right? It's asking you to provide an example of an upper bounded generic type parameter, right? It doesn't matter what, it doesn't have to be any of the things we studied in the course, right? So remember, for an upper bounded generic type parameter, the keyword that you need to remember is extends. Right, so you could write something like question mark extends, and then anything you want here is fine. Right, you could put number, for example, and that would be an example of an upper bounded generic type. Right, the type here doesn't matter. You can use whatever you want. Right, it's the extends part that's important here. Right, so based on those questions, you can kind of guess at what questions you're going to be asked on the exam. Right, so you can just start to think, hey, what kind of variations can he ask me about these kinds of questions? Well, I might ask you to explain what is an upper bounded generic type, right? What is a lower bounded generic type? And so on and so on and so forth, right? So you can sort of guess at the types of questions you're going to be asked. Okay, little programming question. This one asks you to implement a generic type. Right. So part A, it wants you to implement the type triplet. It has 3 public fields. Each has a different generic type parameter. No constructors or methods. Right. So in the lectures, what did we do? We implemented the class pair that had 2 generic generic fields. Now I want 3. What does triplet look like? Well, it looks something like this. Right. So you have a class triplet. It needs 3 type parameters. Give it whatever name you want. I'm going to use T with V. Right. E1, E2, E3, T1, T2, T3, doesn't matter. They're all the same. It all means the same thing. Right. 3 public fields. Public. First one of type T. Give it whatever name you want. I'm just going to call it first. Right. T second. And oops, sorry, not TU. And then V. Third. My advice to you would be that these names are actually slightly long for a test, right? On the test, you want to economize in your writing. So you could call it something like F, S, and T, or A, B, and C, or X, Y, and Z, or something like that, right? Those would all be fine. Don't give them gigantic names, right? If you look at some of the people, some of the tests, people use really long field names, and now you end up writing forever, right? Because every time you need to use the field, you've got to write out this like 20 character long name. Don't do that, right? Try to make your names as short as possible. Oh, sorry. Okay, so now the next question is going to make you use that class that you just created. Right. So the next question says, look, you've got this list of elements. You want to compute some stuff using this list, right? So you want the minimum value. You would like the average value as a double, and you would like to know the number of elements that are exactly equal to some specified value, right? So you want the minimum value, you want the double, you want the average value as a double, you want the number of elements equal to some specified value, right? And now your list, here I'm using S list, but it doesn't matter. I'm just going to use array list today, right? You have a list of some element type E, right? So your minimum value will also be of type E. Do I want the minimum or do I want the index? Oh yeah, I want the minimum value, right? The average value will be of type double, right? So there's your E, right? That's going to be your minimum. So the first element of our triplet will be of type E. The second element of our triplet will be of type double. Right. The third element will be of type integer because it's the number of elements equal to the specified target value. And now it asks you to implement this method. It's not hard to implement, right? You just have to, it's basically asking you to use this generic class here that you just made. Stats. So hopefully I put this in somewhere. Here. Perfect. Right. So there's your method, right, which you were given. And so now all you have to do is make this method. So we're going to return a triplet of this type. So we might as well make a variable of this type right away. You could do it later. It doesn't matter right when you do it. Equals new triplet. Right. You have to remember that you are triplet is a reference type, so you do need to make an object for it. Right. So you can't just write triplet result. You don't actually have a triplet object. You do actually have to make one. Right. And now you compute the stats on this list. right? So you want the, what do we want again? We want the average, we want the, I want the minimum value, the average, and the number of elements equal to sum's target. Okay, so you can do this all with a single loop because you can compute all of these values with a single loop. Right, so we're looking for the minimum. I think the question says assume that the list is not empty as well. Assume that the list, every number is right. Well, I guess it doesn't say that. For the person, no, it does. It says on a large list. So you can safely assume in this case that the list is not empty, so you don't have to deal with a special case in this for this question. So we're going to assume that list is not empty. So we need to keep track of the minimum value, right? So the minimum value in a list of type E will also be an element of type E. Right? I can just assume that it's going to be the first element of the list for the time being. Right? I need to keep track of, what else do we need to keep track of? Minimum, the count, right? So we need to keep track of the count. So how many times target appears in the list? Oh, sorry. How many times target appears in the list? And we need to keep track of the average. So the double, I'm going to use the sum. That. Right. So now you write your loop. Right. That's a list. So you can use for each loop. Right. I only need to access one element of the list at a time. So the easiest thing to do is to write a for each loop. So for each element in the list, right, check is elem less than the min. Right. Now the only complication here is that your list is of type E, right? So it's of reference type. If you want to compare the values, you have to use compare to. So less than, greater than doesn't work here, right? So is elem less than min? So if elem dot compare to min is less than 0. Now, when you're typing this into Eclipse, it's going to complain because we didn't say that E actually implements comparable. We didn't say that E implements comparable E. Right, but that's fine. I'm just going to ignore what Eclipse is trying to tell me right now. Right. So if the element is less than the current min, you have a new min. That. Right. Is elem equal to target? Right. Again, you have to remember your element type is of reference type. So if you want to check for equality, it's equals. Right. So if elem equals the target, add 1 to the count. Right. And now accumulate the sum for the double. So sum plus equals. Now, how do you get the value of E? So if you go back to the question, right? The question says, assume that the list element type E implements comparable E. So that's why we can use compare to, and is a subclass of number. Right. Now, we haven't actually used number yet in the course, but the question goes on to tell you every number object has a method called double value. That returns the value of the number as a double. Okay. So if I need to get the double value of elem, it's just elem dot double value. That your loop ends. You've got your sum. You just need to divide the sum by n, or the number of elements in the list. Right. So sum equals the sum divided by, what's my list? T dot size. Right. So I guess you also have to remember how to get the size of a list. Right. I guess if you didn't remember how to get the size of a list, you could count how many times your loop iterated for. So that would also work. And then finally return the result. Oh, wait, I have to assign the values of the result. Okay, so don't forget to do that. So result dot first. So that's going to be equal to the min. Right. Result dot second is going to be equal to the average, I guess. So it's going to be equal to sum. And then result dot third is equal to the count. And away you go. Okay. So that's the there is using your generic type that you just created in the previous step. Okay, next question. So here's a data structures type question. So this is you're told you have you have a linked stack of some kind, right? Now this question was this question is problematic if you forget how the node class is implemented, which is why it was asked for back here. So if you don't remember that's what a node looks like, you're kind of screwed on this question because you won't be able to answer it. Right? This is asking for a method. It wants you to put a method into the linked stack class, so you have access to the nodes directly, right? It's called bottoms up. So all it wants you to do is you've got a stack. It would like you to take the bottom element of the stack and move it to the top. Right? All the other elements shift down. Right? And so there's also some requirements here, right? So the intent of this question is that you solve the problem by manipulating the nodes in the stack, right? There's lots of sneaky ways you can answer the question, right? You can iterate over the stack, put the elements into a list, right? And then make a new stack having the correct order. You can do other stuff like that, right? But it says don't use push or pop, right? Don't use a separate data structure. It's basically asked, so the question says, look, manipulate the nodes of the stack, right? And so you're stuck trying to figure out how to solve this problem, given that you have a linked sequence of nodes, right? So conceptually, what do you need to do in this thing, right? So conceptually, what you need to do is you need to get to the bottom element, right? And you need to move it to the top. To move that bottom element to the top, you need to sever it from the second last element in the sequence, right? So in other words, you need to get to the 3, and then you need to stop the stack or the sequence at the 3, right? Then you get the 4 and you move to the top, right? And then of course it's a stack, so you adjust what the top now points at, right? So the top now points at the 4, right, in the next step. Don't adjust the size because you're not actually removing anything from the stack. Right. All right, so let's see if we can do this. Here's our linked stack. Where's bottom? I stuck it in here a second ago. I guess I didn't put it in. Okay, so let's put the method in. So it's public bottoms up. And it returns nothing. Okay, so how do you implement this thing? So I guess if you start out ignoring any of the special cases, right, the first thing you want to do is you want to move down to the second last node of the stack. Oh, so how do you do that? Well, you know the size of the stack, so you know how many links you need to follow. Right. So that seems like a good way to approach the problem. Node n. So I'm going to start at the top node of the sequence, like that. Right. Now move to the second last node. So you can write this with a while loop. You can write this with a for loop. It's probably slightly easier to do with a for loop. This particular case. Oh wait, let me just check the question to see. Oh, we do have the size, so that's okay. So this stuff. Oh, sorry, I is 0. I is less than this stuff size. Now you want to move to the second last node, right? So you want to subtract 1 from the size. Like that. Right. And now you just want to advance n each time through the loop. Right. So to advance n, it's just n equals n dot next. Right. And that should move us to the second last node of the sequence. Right. This is basically the move to method from the linked list, right? Where you are passing size -1 as the index into the, where you're passing in size -2 as the index into the list. Right. All right, so now what do we do? So we're at the second last node in the sequence. We now need to, we want to break the link at n. right? But we also need to know what the bottom node is, because I need to move that bottom node up to the top. Right, so at this point, it's now useful to remember what the bottom node is. Right, so that happens to be that n dot next. Right, split the link at n now. So n dot next is now null. Right, and that makes n the new bottom node. Right, all I have to do now is move bottom to the top. So how do you move bottom to the top? When I move it to the top, I need to hook it up to the current head node. So bottom dot next equals this dot head. Right, and then sorry, this dot top, not this dot. Right, so that takes bottom, moves to the top, hooks it to the top node. Right, and then finally update your new top node. So this dot top equals bottom. And that's almost complete, I think. I guess we should test it. There is something that you have to remember though, right? And so the thing that you have to remember is that this loop here moves you to the second last node of the sequence, right? It could be the case that the stack does not have a second last node, right? Which ends up putting n at the wrong location. In fact, it could be the case that n has no nodes in it, the stack has no nodes in it whatsoever, right? In which case, bottoms up should probably do nothing. So if step size, so if it's less than 2, right, there's nothing to do. The bottom node is either already the top node or there are no nodes in the sequence. So just return. And don't bother with the rest of the stuff down here. Right. If I've done everything correctly, I guess we could try to run this and see what happens. The problem with coding this stuff live is that you never know if it's right. So let's see what happens. So we've got a stack A, B, and C. So if I do t dot bottoms up and then print the stack. Oh, linked stack like that. And then print the stack. So with any luck, I've done this correctly. Let's see what happens. And I didn't do it correctly, right? Okay, so what happened here? So go back. What I do wrong? It's probably here, right? So moving to the second last node of the stack, right? So is that really -1 or is it -2? Right. So let's think about this for a second. Suppose your stack has 2 nodes in it, right, or 2 elements in it, right? To get to the second last node, I don't want to go anywhere, right? I'm already at the first node, right? So in other words, you don't want this loop to run at all. So that's -2. Yay, right? So there's our stack, CBA. C was at the top, A was at the bottom. There's our new stack. A is now at the top, B is now at the bottom. And so watch out for that, right? You're always on the lookout for these special cases in these data structure type questions, especially the ones that involve the link sequence, right? There's usually something special that you have to do in certain circumstances. All righty. Last question, I think. So last question is going to be the longest question, although it's not that long. This one was a little bit long. So this one asks you to implement a set, right? But it doesn't want you, it tells you to implement a set in the quote unquote straightforward way. So here we've got a set. It has a fixed capacity, right? So fixed capacity means it has a maximum size that can't change, right? So you can ignore all of that stuff about resizing an array. Right. It also tells you that the elements are never equal to null, so you don't have to worry about null elements, which is also nice. Right. So what's in our interface? It's got a size method, right? So number of elements in the set. It has an isFull method, so this returns true if the set is full. Right. It has an add method. So add for a set adds the element to the set if it's not already there. right? If there's an element that's equal to the one that you're adding, it doesn't add a second copy, right? Set's supposed to have unique elements. And then contains searches for an element. Right? So it asks you implement mini array set that provides this mini set interface. Right? The set keeps its elements in no particular order, so that's nice. The variation on this question would be that the set keeps its elements in sorted order, right? So you're going to have to use compare to all over the place, right? But if it's in no particular order, that makes things a little easier, right? There are some requirements. So it wants you to make a set using an array, right? So don't use an array list here. It says use an array, you have to use an array. Right, its capacity should be 16, so the set size is never larger than 16. Right, and then you have to provide a constructor and equals as well. Right, equals is slightly complicated for this question, but we'll get into that in a few minutes. Okay, so let's implement this thing. There's our interface. I just copied it from the quiz. Right. Here's our class. So I just let Eclipse fill in the methods that we need. And now we have to add our fields. Right. So remember, if you're going to make a collection of some kind that uses an array to store the elements and it's generic, your array type has to be a big O object. Okay. So I have an array. I'm just going to call it 11. But right. So remember, you cannot make an array of type E. Right. Furthermore, you can't make an array that you can't make any kind of generic array. Right. So for example, you can't make an array of for example, right. So this is going to be an array of lists, right? But the lists themselves are also generic, right? They also have type E. So if you make a constructor here, any array set, sorry. Okay, so the no argument constructor is supposed to make an empty set. Right. So we have two fields. I'm going to get rid of one in just a second. Let me import list so that this error goes away. Okay, so if you try to make an array of list E, so this list equals new E n, right? This doesn't work either, right? If you hover over that, it still tells you it can't make a generic array of list E, right? So you not only can you not make an array of type E, right, where the element type is E, you can't make an array where the element type is of some generic type here, right? So that doesn't work. Okay, we don't need that field for this particular question. We just need elem. So you need to make the array. Yeah, you need to make the array. And it says make an array of size 16. So that's easy. Right. Probably going to be useful to keep track of the number of elements in the array. So that makes sense, right? So we're going to keep track of the size. And so for an empty set, the size should be 0. So there's your constructor. Size is easy to implement, right? Just return this dot size. Now, if you're not keeping track of the size, right, the way you have to implement this method is you have to iterate over the array, count the number of non-null values in the array. Right? So you want to keep track of the size, right? That just saves you from writing a bunch of code. Is full. So the array, the set is full if its size is equal to 16 in this case. I suppose the slightly better answer would be this .elem.length. So if the size of the set is equal to the capacity of the array, it's full. Okay, add says add the element if it's not already in the set. Right. So you need to search the array. Yeah, you need to search the array. So for each element E, oh, sorry, for each object, sorry, for each object O in this dot elem, right? I just want to compare O to elem. If they're equal, I'm done. I can return false, right? Because the element's already in the set, and I don't want to add it again. How do I test if O is equal to elem? Right, again, remember, these are references, so it has to be equals. So we can simply return false here. That. Right. Okay, if you get past the loop, it's not in the array, so we can add elem to the array. Right, how do you add elem to the array? Well, it's just like adding to the end of a list. So this dot elem, right? What index do I want to use here? Well, I want to use the current size as my index. Right. This elem. Yep, that's right. Right. Now increment the size of the set by 1. Right, so don't forget to do that. That's always easy to forget to do. Right, and then finally return true. And we're set. So this is basically like adding to the end of a array-based stack, or adding, so I guess adding to the top of an array-based stack, or adding to the end of an array-based list with the added complication that you have to search the array first. Right. Okay, what about contains? Well, guess what? That's contains. Right. So that's almost contains. So we can do this, right? Except now we're going to return true. Okay. If you get past the loop, you've searched all the elements in the array. You haven't found the thing that you're looking for. Oh, wait, this is, sorry, I screwed this up. So I have to go back and fix this. Or false, right? So if you search all the elements in the array, you don't find the thing that you're looking for, you return false. Okay, what did I screw up? I used a for each loop. Right. The problem with using a for each loop in this case is that it looks at every value that's in this array. Right, now remember that array always has 16 things in it. When you make the new array, all 16 things are equal to null. Right, so if you search that empty set, O is null 16 times in this loop. And if you write null dot equals elem, that's going to give you a null pointer exception. Right, so if you want to use a for each loop, you can. You just have to remember to do it the other way. Elem dot equals O, this is fine, right? Anything dot equals null is always false, right? So I guess you could change this one as well, but I suppose the safer way to do this is to use a counting style loop. It's less than this dot size. And now we're going to do, sorry. Oh. And here we're going to do object equals this dot elem I, like that. What's it complaining about? Syntax error on token. Oh, expect. Oh, yeah, right. Equals. Here we go. So I guess that's the better way to do it. So let's copy that into here instead. Make that true. Right. And if you're looking ahead in the question at this point, right? So in other words, if you read the question, you say, hey, look, I can implement adds as long as I know if I have contains, right? You can now get rid of this. Right, and if this contains elem, false. Right, and now you don't have to write your code twice. Right, if you do things in the order that they're presented, unfortunately, you're probably going to be stuck writing your version of contains twice, but that's fine. Okay, last part. We have to. The question asks for. After we did that, it wants an overridden equals method. The complication here is that it wants you to test if the set is equal to another mini set object, right? So in other words, it's not asking you to test if a mini array set is equal to another mini array set, right? If it was, then you can exploit the fact that both of them have an array inside of them. This one's asking you, can you test if a mini array set is equal to another mini set object? So that complicates things slightly. So step one, you have to remember that equals always looks like this, right? It's never equals mini set, right? If you're going to override it, it's always equals object. Right. So now you do all of the usual equal stuff, right? So if this equals obj, return true. Okay, now you have to remember, so this is because we're comparing, we want to compare our set to the interface type and not to another array set. You have to use instance of here, right? So if not instance of, sorry, obj. Not once mini set here. Turn false. Right. Okay, so now we know that we do have a mini set, so I need the cast here. So mini set, something it's gonna bark, it's gonna complain here. I'll explain that in just a second. Obj, but now it should complain, and it does. Right. So we never talked about this in the course. There should be 2 complaints here, actually. Anyway, that's fine. So if you hover over this, it's going to complain that there's an unsafe cast here, right? Unchecked cast, right? So you're casting obj to a mini set object, right? Even though you got past the instance of test here, right? You can just ignore that. The cast we know is safe because we got past instance of, right? And now you have to look back at the question and see what the heck is the question asking, right? So it tells you this set is equal to another mini set if both sets have the same size. So we're going to test for the size, right? I can test for the size because the mini set interface has a size method in it, right? And if each element in the set is contained in the other set, right? To answer that part there, you're going to use contains, right? Which also comes from the interface. So we can test the sizes first. Oh, sorry. So if this size is not equal to O size, we're going to immediately return false, right? Okay, I now need to test, is every element in this set contained in the other set, right? So for, again, I want to avoid the looking at all the elements in the array. So I'm going to get an object out of my array. I can't use O, right? O, this dot lem I. Okay, I want to know, is that element, right, in my set, right? Is it also in the other set? Yeah.
Check the type of mini set.
We'll come back to that in a second. That's a good question. I was hoping you wouldn't ask. All right, so I'm going to grab an element out of our array. I'm now going to test, is that object in the other set, right? So if not, O contains elem, right? So if an element from my set or this set is not in the other set, I know the answer is false. Right. If I get past that for loop, we know that the sizes are the same. Every element in this set is also in the other set. Because the sizes are the same, every element in the other set is also in this set. And, right, the sets are unique, right? They contain only unique elements. So we can safely now return true at this point here. Okay, what back here? Why did I not test? So why did I not write that instead? right? And it's because if you write that instead, your compiler will complain, right? So your compiler complains, it says it cannot perform an instance of check against the parameterized type miniset E. Use the for miniset question mark instead, since further generic type information will be erased at runtime. So Eclipse is trying to tell you it wants you to write that, but it doesn't explain why you can't write that, right? And so when we talked about generics, I didn't tell you how Java actually implements generics, and it's funny how it does that. We're actually over time. So if you want to go, you may go, right? I'm not going to ask you about this on the test. The answer to your question, though, is that the way that Java implements generics is that the compiler does all of the type safety checking, right? So when you put something into the list, it makes sure that the generic type matches. You can't put a string into a list of integer. The compiler does that checking for you. After the compiler compiles your program, it tosses away all of the actual type information. So if you have an array list of integer, your virtual machine doesn't actually know it's an array list of integer. It just knows it's an array list. The reason it does that is because when they stuck generics into the language, it was a late addition, right? So it showed up in version 6 of the language. They could not include the type information at runtime and still have all of the classes be compatible with the way they used to be implemented. So it's a funny Java thing, but that's why you can't test for the actual type there. If you wrote this on the test, it's fine. No one's gonna ding you marks, right? But when you write it, you always write it with a question mark, or you don't use the type at all. All right. I wasn't expecting to finish that, but we are done. We are through that test.